Hello everybody and welcome to this latest video discussion as part of the RICS Tech Partner Programme. My name is Andrew Knight and I've been with RICS now for over 11 years. I sit within the standards, regulatory and thought leadership part of the organisation, and my job role is to look at the overall effect of data and technology right across the built and natural environment. And with over 110,000 qualified members worldwide, working right across the property life cycle through land, planning, development, construction, building operations, brokerage, valuation, finance, end of life. Our members have a huge opportunity to take the benefits of data and technology as they work across a whole range of asset types through land itself, rural land, residential, commercial, alternative assets and infrastructure. So as I say, data and technology has a huge positive effect on helping our profession to generate even more value for their clients. And I'm really glad this afternoon to have Steve Carrington join me from Ocuair. So Steve, join me on the call if you would. Hi, afternoon, Steve. Now, before we get into the bits and bytes, it's always nice to have a bit of a kind of a human background story. So it'd be great to hear about a bit about your background and the kind of backstory and origin story of Ocuair, if we could.
Yes, well, I spent 30 years, or just shy of 30 years, in the army, and when I came out, I decided that I needed to carry on working and doing something, and we ended up in a situation where we set up one business where drones were a minor part of it, and suddenly realised partway through developing that business that actually drones offered a huge growth area. And so pivoted and then set up Ocuair with a real focus on the built space, because we saw that as being a growth area, and particularly adding thermography into it as well. And so that's where we sort of came from, and as such we spent about the last 8 years building our practices, techniques, and building confidence with the CAA in terms of making sure that we can get the right permissions to be able to work. Innovation's key. We were the first to fly across the channel with a multi-rater. And a number of other areas where we've tried to push the envelope. So that's where we see ourselves sitting in terms of developing new projects, as well as and ideas, as well as inspecting routine built space for defects and all the usual bread and butter stuff that needs doing.
Exactly. So in that sense, as you say, there's that kind of bread and butter space that people perhaps are familiar with. But, how more broadly can drones contribute in increasing our understanding of the built space, given the variety of built spaces that are out there as well?
Oh, absolutely. I mean, in short, the real benefit of the drone is it's a skyhook for a sensor. It allows us to put a sensor in an otherwise quite difficult place to get that sensor, because it's dangerous, because it's difficult to get to, because it's uneconomic to get to, and it allows us to hoover up large quantities of data over quite large areas, and the benefit to that is, from a surveyor's perspective, is the possibility of generating much greater understanding of what's going on where you can't see or where it's difficult to get to. The real power, though, from my perspective, is when you can combine that data with other data sources, and then you get the 1 + 1 equaling significantly more than 2 benefit. So, when you combine it with ground-based data, with data loggers, with scanners, you can generate real understanding of the whole envelopes of buildings and structures, and produce comprehensive digital records. And I think that's another area where we can really see some growth. We've seen a huge change in 8 years, and there's a real appetite now for that digital information. You can see that growing. 8 years ago, surveyors wanted photographs of a roof, and they analysed them themselves, and they did all of the other work. We're much more involved now in generating a kind of path to insight by using different mechanisms and different data feeds, and smashing that all together to try and create some correlation and some better building intelligence, and also generating some more empirical evidence as well. And of course, all of that digital means that you can use that. You gather it once and you can use it several times over, many times over. So as a technical partner, it's not just about flying drones, it's about trying to advance our ability in this really ever-changing environment to work with surveyors to understand their needs for digital data acquisition, of which drones, is obviously a key part in what we do, but it's by no means the be all and end all.
Now, I suppose in some sense, it's almost that sort of second generation thinking around the use of drones, that when they first came out, it was, well, these are our eyes, we can now look at the roof. But what you're really saying there is it's gone beyond that now to be almost not so much the roles reversed, but arguably you're looking at producing a data set where perhaps the drone is only actually producing a fraction of the overall data. It's a critical part, but you're looking at really whole asset data, with the drone being one of the sources that gets you part of that overall picture.
Absolutely. Yeah. And so on a typical retail unit now, we'll provide a whole variety of different data feeds in order to be able to provide, an understanding of that building's condition. We'll go externally, we'll put a drone over the top if it's flat roofed. We'll put a drone over the top and we'll look for trapped moisture. We will go inside, we'll look for, using thermal and visual techniques, look for water penetration and heat egress and cold air ingress. Outside, we'll do a visual inspection, particularly on a lot of retail units, combine flat roofs, often with mansard tile pitches around the sides and those sorts of things. So we can wrap that up as part of the visual inspection. We may well run electronic leak detection over the surface in order to understand where penetrations are, particularly where there's lots of seagulls, because they're obviously one of the culprits. And then you smash all of that together, and you can provide a really good understanding of what that roof's condition really is, and that really helps inform the repair replace decision-making process the surveyor has to come to. And I think what's really important as well is it provides a visual information that the surveyor can share, often with a non-building expert, in order to understand the sort of extent of the issues that might exist in a very easy to absorb way. And it's a very powerful decision-making tool in that respect. And I think that's what this is all about. It's about empowering the surveyor with that sort of evidence to be able to make those decisions and give that advice and be more compelling in the way that is presented.
And I guess as I think and listen to what you're saying, you mentioned roofs, and there's always that classic thought process of, frankly, that the risk involved sometimes for surveyors actually getting to physically inspect some parts of an asset. So I guess there's a big role here about reducing risk as well, in terms of either totally removing the need for a surveyor to go to a certain location, or perhaps helping them with that risk assessment when they look at an asset and say, well, where do I actually physically need to get to?
Yeah, absolutely. And because most of what we do, other than the electronic leak detection aspect, is ground based, then obviously the safety concerns are very different. We don't have the working at height issues that we'd necessarily have. And the other aspect of risk, of course, is that if we accept that risk often stems from knowledge not being complete in its widest sense, that uncertainty, then we have a role, a significant role to play there. We often tell people, if they've come to us with a particular problem, that a cherry picker in certain circumstances is the right thing. If they want to understand the condition of their water goods and they've got storm damage and they want to see whether the water goods are still firmly fixed in place, and a cherry picker is what they need to get up to that height and do that. But if they want to understand the entire roof condition, then the problem of going up in a cherry picker and looking across a roof and trying to extrapolate from that snapshot what the overall roof condition is introduces a level of risk. And the benefit here is that if we then fly across it and digitally capture the whole of that roof, then you now have that digital record. You have that basis on which to make a decision. If you add in other techniques as well, then you're removing that process. So that risk reduction, I think, is a really important aspect. The other thing that we found that's really interesting is that when we did some work for the university in Bristol, and they have lots and lots of buildings that have been given to them as part of the campus redevelopment, and one of the challenges they had was prioritising across all of those buildings, not all the same building types and styles. And one of the benefits here was we're able to gather all of that information and then grade the various issues and come up with a prioritisation process. And when they put that out to tender, what they found was they were able to embed quite a lot of the visual information and the thermal information we provided in the tender process. So the tender itself was more tautly written, which meant that the bids that came back could be much tauter, because there wasn't as much risk for the guys tendering who were looking at the problems, and they were able to really tighten up their access rather than scaffolding the whole building and seeing what they found when they got up there. They were able to target that work. And the other thing that was quite interesting as well was that they felt afterwards that that there'd been a tendency for the quality of the work to be better, and they surmised that that might have been the fact that the people tendering knew there was a very easy way in which all of the work could be inspected 5 stories up subsequently. And so all of those things obviously added value. And that's a two-edged sword. We've been used by those who completed the work in the past in order to prove the fact that their work is to the highest standard, and to release their retention and allow them to leave the job. And subsequently, then, when damage has appeared, because other trades have used the roof in order to get across it to do other work, there's been that evidential trail, so that then you can start to unpick where the damage actually, and when the damage actually occurred. So there's lots of advantages of this digital data gathering.
Indeed. And I think last time we spoke, you used the kind of phrase high impact, low cost property technology. Could you kind of expand on what you think that means for ultimately the end users who are using this approach?
Yeah, there's a lot of really good tech out there, and it's not all expensive. The real benefit is if you can bring that technology to bear in a slightly unusual way and exploit it in a slightly different way. So sometimes where we've been unable to fly because we did some work near the MI6 headquarters, and we weren't able to fly. So we developed a rig which we suspended out over the side of the building and used the drone technology and flew the drone by lowering it and raising it on cords over the side of the building, gathering all the information, using the sensor technology, everything on board, gathering that data in an area that otherwise we'd have been able to fly. And we're getting a cherry picker in, quite frankly, and the road closure aspects of doing it near Vauxhall Bridge were complex. We're just about to do another job where we've built a platform. We've effectively, I've stolen my daughter's surfboard, and we're putting a drone on the surfboard, and then we're going to float a line down through a fast-flowing culvert, which we know has got some issues within it. And unfortunately, although it's probably just about big enough to fly into, it's got service pipes that run horizontally through the actual space. So you can't get anything really in easily. And the idea is we're going to float the line through, attach it, and then pull the drone upstream back up through with loads of illumination on it, again using the camera in order to be able to view the inside of that culvert. So there's no confined space, there's no water, all of those risks and issues and problems that come with operating in a space like that. The only thing that's at risk is a piece of rope, my daughter's surfboard, and an old drone. So this is where this sort of technology can be leveraged and used in different ways. We've got a Matterport scanner which uses infrared for scanning, and that's brilliant. And I've seen it used to really great effect by estate agents and the like in order to showcase property. We've used it to map and model the ventilation system underneath Strathclyde University's Royal Building in order to understand the layout, because they didn't have any sort of high quality drawings or understanding. They had bits and pieces, but they needed the detail, and also were then able to correlate between the ventilation routes and the shafts that went up into all of the classrooms and lecture rooms above. Again, using Matterport in a slightly unusual way. We've also used it for mapping Bath stone mines near Caution, about 15, 16 acres. It was the perfect tool for that kind of environment. It was remarkably quick. And so as a tool, it's not a particularly expensive one, but we're able to use it in a way where you could add significant value. The point cloud gathering capability that it offers is really is really effective for those kind of jobs where high levels of accuracy are not fundamental to what you're doing, but understanding the context and getting, you know, an approximation of the problems and the size and the shape and the scale, you know, it's the perfect tool.
No, and I suppose it's a great example that not all technology is necessarily complex. It's about solving problems with the tools that you have at hand. And at one extent, as you say, it could be a surfboard or a puppeteering approach to MI6 in that sense. So I know you've got some visual stuff you could share with us. Could you show some other examples about how you've kind of, as you say, you know, effectively both managed risk and delivered real value by these sort of mixes of data sets? Because I think that's a really interesting part, that it's gone beyond just it's a visual drone, but no, you have these other kind of data sets that you've used.
Yeah, let me just share a presentation with you. So this was a large building, 25,000 square meters in South Wales, where there were large problems with a leaking roof. So the first thing we did was electronic leak detection. About 1,200 penetrations were detected. It's each of those windows or those skylights you can see is 8 foot by 4 foot, and there you can see the yellow circles where we've marked each of the penetrations. Then we did the thermal to understand where the water was trapped, mapped that over the building, worked inside to understand where water was penetrating using thermal again, and then provided that overarching map, which was then used to make a decision as to whether to repair or replace. And the real benefit was that what we discovered was, rather than the roof being completely waterlogged, there was about 6% of the insulation needed to be replaced, and the top sheet overlaid and resealed. And the benefit there was that we ended up with 94% of the insulation not needing to go to landfill, which was a real win as far as we were concerned in terms of the ecological benefits, as well as obviously significant financial benefit. With the high-grade thermal imaging cameras, we can detect not just the large areas of moisture penetration underneath the single-ply membrane felt or other warm roof types, but also the more small and localized areas. And this work is done just after dusk. And when we then combine it with the electronic leak detection signatures, we start to see some correlations between where we have penetrations and where we have moisture. Because with electronic leak detection, not every penetration is a material point of entry for water. Obviously, it may well become one day, but isn't necessarily the case today. So correlating that data, bringing these different technologies together, really important. Also working inside, this is a domestic property, the real benefit is we can start to see in this particular case where we've got cold air ingress, where we've got missing insulation, so a number of different issues. There might be moisture getting in there as well. And what this allows the surveyor to do, having seen this, is target where the more invasive techniques may be necessary in order to be able to see what's going. This particular case, we did visual, we did thermal, inside and outside, in order to be able to understand what was going on, and again areas of missing insulation. From an external perspective, and particularly at the moment with energy costs rising, a lot of issues with regard to cavity wall insulation. In this particular case, we've got wet insulation, which is causing a thermal bridge at the bottom. In this particular case, we've got missing insulation, and you can see there where the fill has not made it all the way to the top of the building, and we have that classic V shape where you have no insulation, and then the area below it in the green or colder showing where there is good insulation. So these are sorts of the classic techniques that you can use, and this is using the same technique but on a high rise. The benefit here, 15 floors up, is we can see we've got moisture penetrating behind the render. But more importantly, it also allows us to detect whether or not there are fire breaks behind the render in place. So from a post-Grenfell perspective, in terms of understanding whether or not the fire breaks are in place and the buildings to code is really important. And if you look closely, you can see the dots, and those dots are the thermal signatures of the stainless steel fixings for the fire break. So we can even, using these techniques, understand whether the fixings are the correct distance apart to meet current regulations. And it goes from situations like that, where you've got small amounts of water penetration, through to areas where you've got large amounts of water penetration. There's a potential for render to actually come away and present a hazard below. And the real benefit here, of course, is that then, if there, whatever the solution is, there's a targeted approach can be made to deal with that particular problem. As part of this project, the work that we did led to opening up at a much lower level in order to understand what the thermal signature that we were showing on the 15th and the 14th and the 13th floor might be. So they were able to open up on the first and second floor, see what those thermal signatures represented. In this case, as you can see, there's a rectangle being cut, and that was where work's being done on the building, and lifts have been fixed to the side of the building, and they've been fixed at floor plate level, which is the greatest strength, cutting across the fire breaks. And that when that building was repaired, they'd put a single piece of polystyrene in and had breached the fire break. So it identified this problem. The council were then able to fix it. And in this particular case, it allowed them to identify that those signatures were the stainless steel fixings associated. So they were able to then correlate that up the building. And it's meant that in those particular tower blocks, there's been a lot less invasion. There's been a lot less disturbance to the occupants, and yet they've been able to see the advantage, but also identify the issues quickly. And we've just been doing some work in a quite a large conurbation where several blocks of flats are about to be built, apartments about to be built, and there's a large piling programme. And so one of the things that we were asked to do was to do all the buildings that surround the area and to understand the condition of the buildings before the piling starts, in order again to de-risk the whole process. One, because the engineers associated with it didn't want a building that was damaged to be further damaged and cause a problem, but also wanted to make sure they were protected from claims subsequently. And as you can see here, this particular chimney has quite significant issues, and actually, if you drop down and look through it from a slightly different angle, you can see daylight through the chimney, which wasn't particularly good. And there were a number of concerns around which they were able to then get fixed before the program of work started. And then the traditional sort of thing you would expect with listed buildings in terms of understanding where things are good and bad and need fixing, but more importantly, again, from a risk perspective, a physical risk perspective, finding the risk to people below. And making sure that they're dealt with appropriately. It's surprising how many times you spot things like that, which you can see from below, but it's amazing how many people don't actually necessarily notice it. And this is a church steeple in London. As you can see, there's been a number of issues, and there's a piece of masonry that may well be likely to depart it. And being London, of course, the church is surrounded on two sides by a road. And of course, there's some more interesting stuff. This is work inside the Royal Albert Hall, flying a drone in a cage, looking at plasterwork of the ceiling, trying to understand conditions. So it's not just the outsides of buildings, it's the insides as well. And the other thing that's really important in risk terms is being able to then subsequently go back to the data and understand where the data relates to. So we have a piece of software which is quite useful in terms of recording where every image was taken, which serves two purposes. One, it provides a great record, but also when you go back, it means you can go back and find that and check check the state of the building at the time. You've got that benchmark to go back to in order to be able to understand it. And this is a bit of work we did with Matterport, which is really useful in terms of understanding how this might be useful in terms of digital twin, understanding condition, and in a very low cost way, starting to move forward the as-built BIM ideas and capturing that data digitally and then adding to it. And the new module which scans straight to Revit, extremely useful from Matterport in that respect. And again, a relatively low cost solution, providing probably something that's good enough. And I think that's the most important thing here, is that all too often we get caught up in trying to deliver to people's wants rather than people's needs. It's really important to understand how we can deliver what is good enough to meet the client need, rather than getting bogged down in the technology. We did some work for a local authority, and they asked us to scan to 15 millimeters on some spall heaps, and then subsequently the output they required was 1 meter contour lines. And so we'd spent a huge amount of time gathering data that was utterly unnecessary. And so it's really important that we understand the requirement so that we can best fit that. And that's not always easy, and it's not even easy for the surveyor to get that out of the client and to really understand that. I hope that makes sense.
Yeah, and I suppose it's that old cliche, isn't it? Don't let perfect be the enemy of the good, depending on the context of what you're trying to do. Because as you say, tolerance and accuracy is all about context. You clearly need huge levels of tolerance for different kinds of applications. That was incredibly informative. And one thing that strikes me is our profession will be, to a large extent, very familiar in some ways with drones. But what do you think are the big takeaways out of this in terms of what they should be seeing as new, given the way you've been, crashing these data sets together? What would your summary be that to our profession of what's new here? What should they be taking advantage of that perhaps they've just been using drones in perhaps put it rudely, kind of a one-dimensional way, if you get my sense?
Yeah, well, I think what we're starting to see, particularly from the really tech-aware group, the young guys coming through, really engaged. There's a whole series of stuff I haven't gone into here that's not gaming, but it's much more about virtual. It's much more about stepping into a slightly different space in terms of the way data is presented. Now, a lot of people are not yet comfortable with that, but that's coming. I think what we are seeing in terms of a change is that we've got ever smaller, ever more capable sensors, which means we can load more on the drone. It's a more capable machine, or it's capable of much greater endurance. Actually, for the built space, I don't think endurance is critical. It's more about being able to put it into really difficult places and make best use of the sensors. What's really fascinating is the increasing use of cloud-based computing, which means that huge amounts of processing power can be brought to bear for short periods of time. And so the complexity and flexibility that gives you in terms of being able to create really powerful outputs very quickly, I think is going to really change the way that we look at data. So three-dimensional modeling and the ability to produce high-resolution three-dimensional modeling, I think is very close. I mean, there's always a challenge, because most of what we're doing here is modeling through motion. It's photogrammetry, and so it isn't the same as LiDAR scanning. It's an unreferenced point cloud, but I see there a closing down of that gap, and there's an increasingly competitive market, which is great because that's driving the price down for the users. So I think rapid 3D visualization is going to become much more accessible, and I don't think that's just a drone thing. You know, I see that from, from being able to walk. You can get these systems now for your iPhone where you walk around and stuff, and you can see how the power of that is really developing. But the ability to gather that, store it, and represent it and mark it up, so that your reports have a much more three-dimensional, to step away from paper, to step into a three-dimensional model of a building and then walk around it virtually and see all the issues associated with it, and the general capturing of condition and all of those things, I think, is, from a lease perspective and those sorts of things, absolutely fantastic.
Yeah.
For drones, the next big steps, I think, are undoubtedly, and we're involved to a certain extent in this, with increasing autonomy, with swarm technology for data acquisition. And we all saw the fantastic drone display over Buckingham Palace, but there's real world, inspection utility in that sort of technology. The increasing use of obstacle detection and the ability of the drone to map its own path and to find an intelligent route. Its linkage into the overall aviation ecostructure is going to be a massive step forward and give huge freedom, because it's going to mean that we're flying in a positive way rather than we're currently flying in a very defensive way. And I think as well, the whole issue of AI and machine learning and the ability to interrogate that data and remove the human from the drudgery of the analysis and put them into a much more intelligent role where they're assessing the variations that are thrown out by the machine analysis, means that those property building experts' knowledge will be used in a much more effective way rather than looking through loads and loads of data or walking large distances trying to gather data themselves. Drone in a box and other platforms in a box where they are located on site, they charge and they're linked digitally, means that the whole concept of monitoring and managing, say, a retail park or an industrial estate or whatever, can be done in a completely different way. It can be done in a repeatable way. It can be done in a relatively effortless and low cost way. I think all of those offer massive opportunities. And that whole idea of remote sensing, monitoring, analysis, and then identification to experts of problems or of changes of anomalies means that surveyors will the role of the surveyor may shift. I don't think it's fundamentally a threat at all. I think what it offers is a real opportunity in that respect. So it's a fascinating time and a time of exponential change. And I think the fundamental for us this week that we've seen, talking to the CAA, is that we've seen that there's a whole new regulatory approach that's a much more permissive, much more supportive environment than we've possibly seen in the past. And I think that's absolutely amazing and offers huge opportunity.
Right. Well, I mean, it's lovely to hear that kind of a theme you've been talking about, effectively, that technology is there to augment the surveyor. It's not to replace them. It actually frees them from the drudgery, if we can use that word, of data acquisition. It means they can really apply their expertise to the interpretation and the decision making, which I think is genuinely a common theme about so many of the pieces of data and tech that we look about and look to. Well, it's been fascinating to chat, Steve, and thanks very much for your time today. And I look forward to catching up again and seeing what the next evolution looks like. But for today, thanks for your contribution, Steve.
Absolutely. Great to talk.